He had said that you wanted.
Alright, well then just roll it so that it's along the
Pete's physics class is never boring, and this week was really interesting again. Let's have a short journey through this week's topics and experiments. We started another ball experiment, except that we rolled the ball from a high position off the edge. We tried to measure its velocity and had to care about 2 directions of the ball's velocity this time, as we had 8 x directions.
Didn't go very far that way.
Okay, ready?
Hang on.
Oh, because the measuring cup goes like off.
And not just falling, but
Yeah. Ready?
Okay, hang on. Yep. Is recording the motion between basically here and here, something like that. So we. Okay. Pretty good.
Gravity was very important in our this week's classes, and how it has an impact on falling objects or on objects that are thrown up. Using the Looker-Pro free software again, we were able to have a look on our data.
To go from 30 frames per second to. So that's one.
Try to get right in the middle. See that? I don't think that one was right in the middle. Was it?
Well, like the middle of that doesn't like.
Yeah, the middle of the blur is where you want to put it.
So here's what, now just go back
Right smack in the middle.
Yes,
That's,
I would. Yeah,
be
those are frames.
very
Like
accurate.
frames. Go click, 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 click.
Try to get it as accurate as you can.
No, stop, don't. You don't want it right there. You want to get a few. Now go, yeah, that button. And then let's get our, let's do the meter stick first.
Yeah.
You remember which one is the meter stick? No.
But does
It's
that
okay, just do the
advance
best you
frame?
can.
Yeah, that advances the frame.
According to this experiment, we learned about vector resolution, which is the process of determining the magnitude of the components of a vector. For this, we went outside and did another experiment. With the help of a squirt filled with water, we tried to spray the water from different angles to see in which angle the x velocity and the y velocity would be even.
Which squirt of water stays in the air longest? Okay, so this one or this one?
That one?
This one?
Yeah.
Yeah.
Why?
Because it's straight up in the air. It isn't like vertical.
It had a y velocity.
Okay, it has a
A
y
positive y velocity and.
So it has a positive y velocity, meaning that what's going to happen to the teeth?
It's going to be longer.
Yeah, we're going to have more time, right? Because we have more velocity until we get to the arc of the point.
Yeah.
Exactly. I have the best angle that will give you the most time.
Right. So what happens to the x velocity here of this? Is it being accelerated? X
Yeah.
velocity.
After it leaves the tube, it isn't.
That's right. So if we want to get it as far down the way as we can, we want to have the maximum amount of time, right?
Right.
Yeah.
So the question is, what angle will give us the maximum amount of time? Only when it's vertical.
Yeah.
This.
Oh, yeah.
Is that about right?
Yeah.
Okay, somebody watch this and stand where the last drips are. Click right over there.
That's a little farther.
Okay, then we'll go to 45. You have to take into account that there's air resistance.
And wind.
And wind.
Different.
But if there
But the
wasn't
energy
air
he
resistance,
exalts.
let's go back.
45.
Okay, let's go back in and take a